Yes.
Sound കുറവാണ്.
Okay, ഇപ്പോൾ സൗണ്ട് കേൾക്കണ്ട?
സാർ ഇപ്പോൾ കുഴപ്പമില്ല, ഇപ്പോൾ ഓക്കെ.
Okay. So instantaneous center, first go through the definition of instantaneous center. It is a point on a member which another member rotates around. So we are speaking with respect to the 4-bar mechanism or slider crank mechanism, etc. So in a 4-bar mechanism, point on that 4-bar mechanism in which corresponding to the point another member rotates. That rotation can be either permanently or instantaneously. So that is your instantaneous center. And the instantaneous centers, they are classified into different types. They are fixed instantaneous center, permanent instantaneous center, neither fixed nor permanent instantaneous center. Neither fixed nor permanent instantaneous center. So we will go through the definition of and the types of instantaneous centers. So you know what is instantaneous center, and next is the types of instantaneous center. So first is fixed type. Fixed type instantaneous center. Fixed type instantaneous center. Fixed type means, the fixed instantaneous center means you consider a 4-bar mechanism. Just consider a 4-bar mechanism in which the link number 1 is fixed. Link number 1 is fixed. So that corresponds to, see here you can see. Here you can see link number 1. Here you can see in the figure link number 1 that is fixed. Okay. So the point on the member around which the other members rotate. So you can see 2 points. These I14 and I12, they are on the fixed link. So those points which are on the fixed links, they are called fixed instantaneous centers. So instantaneous centers for a mechanism are of the following types. First is fixed instantaneous center. Second is permanent instantaneous center. And third is neither fixed nor permanent instantaneous center. First 2 types, fixed and permanent instantaneous center, they are called primary instantaneous center. And third type, neither fixed nor permanent instantaneous center, it is called secondary instantaneous center. So we have to go in detail with what is fixed, what is permanent, what is neither fixed nor permanent instantaneous center. Fixed, you have already seen. The fixed instantaneous center corresponding to this figure is I14 and I12. So why I14 and I12 are called fixed instantaneous center? Why? Because they are on the link 1 which is fixed. So those 2 instantaneous centers are called fixed instantaneous centers. Then you can see the other instantaneous centers I23 and I34 are permanent instantaneous centers. The reason why they are called permanent instantaneous centers are they move when the mechanism moves. So those 2 points, they move when the mechanism moves. Mechanism move cheyyunnadinusariche those 2 points will move. So those 2 points, they are called permanent instantaneous centers. Then you can see another 2 more instantaneous centers which is outside the figure, which is I13 and I24. They are neither fixed nor permanent instantaneous centers because they will vary along with the configuration of the mechanism. They changes according to the configuration of the mechanism. Whenever the configuration changes, they change. So they vary according to the configuration of the mechanism. So first to go through the definition. What is instantaneous sender? It is just a point on a member which another member rotates around, and that can be, so it is all the instantaneous senders, they are the points, and it is a point on a member. Means either it can be on a 4-bar mechanism or slider crank mechanism or any other mechanism on which another member rotates around. That is called your fixed instantaneous sender, and it can be of 3 different types. First is fixed instantaneous sender, second is permanent instantaneous sender, third is neither fixed nor permanent instantaneous sender. 1 and 2, that is fixed and permanent instantaneous senders, they are called primary instantaneous sender, whereas the last one, it is called secondary instantaneous sender. So first 2, fixed and permanent, are called primary instantaneous sender, and third one, it is called secondary instantaneous sender. Neither fixed nor permanent in parayana perana secondary instantaneous sender. Then the question is, why the first one is called fixed instantaneous sender? The fixed instantaneous sender, why? Because they are on the same link. I14 with respect to this figure, I14 and I12 are the fixed instantaneous sender. The reason is they are on the fixed link 1. Then I34 and I23 are the permanent instantaneous senders. Why they are called permanent instantaneous? Means they are called permanent instantaneous sender means they move when the mechanism, these instantaneous senders, they move when the mechanism moves. And I13 and I24, they are neither fixed nor permanent instantaneous senders, which is outside the figure, and they vary with the configuration of the mechanism. They vary with the configuration of the mechanism. So here you can see Deepak.
Yes, sir.
Deepak, by looking at this figure, 4-bar mechanism, how many number of instantaneous senders are there total?
6.
Yes, 6 instantaneous senders are there. So there is a question which you can expect in your competitive examinations, gate examinations, and your university examinations. In a 4-bar mechanism, the total number of instantaneous sender is. In a 4-bar mechanism, the total number of instantaneous sender is. Okay, so this is the equation. Here you can see, in a 4-bar mechanism means the number of links is 4. So small n corresponds to number of links. Capital N corresponds to number of instantaneous senders. So in a mechanism, in a 4-bar mechanism, the total number of instantaneous sender means small n is equal to 4. Substitute small n is equal to 4. So you will get 4 into 4 minus 1 means 4 into 3 divided by 2. 12 by 2 is equal to 6. That is how we studied all the fixed, permanent, neither fixed instantaneous senders here. Okay, altogether 6 instantaneous senders are there that you calculated from this particular equation. So this is how you will locate the instantaneous senders by using the equation n into n minus 1 by 2. So last time for your university examination, the question asked was, calculate the number of instantaneous senders in a mechanism with number of links is equal to 10. Number of links is equal to 10. Calculate the number of instantaneous senders, one word question. So 10 means 10 is the small n given, small n value which is given. So 10 into 10 minus 1 by 2, that is your answer. Okay, that was last time or previous year university question. Calculate, or one word question, calculate the number of total number of instantaneous senders in a mechanism with 10 links. Okay, 10 into 10 minus 1 by 2. So that is how you will calculate the total number of instantaneous senders. Now here you can see another one word question for your all the competitive level and all other examinations. You can see, look at the figure A. Figure A. Okay, figure A. Look at the figure A. Figure A, you can see two links. Link number 1 as well as link number 2. Link number 1 as well as link number 2. You can see link number 1 and link number 2. They are just connected. They are just connected. As in case of now we have studied four bar mechanism. So in that you have seen there are 6 different instantaneous centers. In that there was 4 links, and you calculated by counting all that 4 plus 2 additional, total 6 instantaneous centers was there. So whenever there are two links like as shown in the figure A, the point connecting that two links will be that instantaneous center. Means that particular joint, that will be your instantaneous center. Instantaneous center. Okay, then look at the figure B. Look at the figure B. Figure B, when two links have a pure rolling contact. Pure rolling contact. That means your their point of contact. Instantaneous center lies on the point of contact. So here the situation is link 2, which is a disk, rolls without slipping on the fixed link 1, which is straight. Here the fixed link 1 is, it is straight. So link 2, which is a roller or disk, that disk rolls without slipping upon the fixed link 1, which is straight here. So it can be either curved also. So link 2 rolls on the fixed link 1, which is straight. In that case, instantaneous center lies on the point of contact, on their point of contact. So that is another situation. What about the case 3? What about the case 3? Anyone who can tell by looking at the figure C, what is the situation there in the figure C? Archana, IB, Archana? 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 Vishnupriya?
Sir, അതിന്റെ സെന്റർ തന്നെയാവോ?
Look at the situation in the figure C. What is happening in the figure C? In figure B, I mentioned a disk rolls without slipping on it.
Slipping.
That is the situation in figure B. What about the situation in figure C?
അത് slide ചെയ്യല് with
slider. There is one slider which is linked to that slider. എന്താ ചെയ്യാ? Slider moves on a
slider moves
what
plane,
type?
vertical plane.
Vertical plane എന്ന് പറയാൻ പറ്റില്ല. That is a fixed link. Okay, slider moves on a fixed link. Slider fixed link 1. That is the situation. So that is the difference between the two situations, B and C. So in C, slider moves on a fixed link 1. What about the instantaneous center? Your answer, what about the instantaneous center? When the slider moves on a fixed link 1 having straight surface, the instantaneous center lies at, anyone answer? When a slider moves on fixed link having straight surface, the instantaneous center lies at anyone. Instantaneous center lies at. It is given here. Instantaneous center lies at. Instantaneous center lies at
Infinity.
infinity. Answer is infinity. Okay, answer is infinity. Instantaneous center lies at infinity. So remember the question. When the slider moves on a fixed link 1, slider moves on a fixed link 1 having straight surface. Vishnupriya Varna bole, having straight surface, that is very important. Having straight surface, the instantaneous center lies at infinity. Now look at the figure D. Figure D. In that case also, similar to the case number C, slider moves on a fixed surface, that is correct. But here the fixed surface is not straight. Okay, here the fixed surface is not straight. That means slider moves on a fixed link having curved surface. Curved surface, having curved surface. What about the instantaneous center? Instantaneous center എവിടെയായിരിക്കും? D എന്ന് പറയുന്ന കേസിൽ where lies the instantaneous center? Anyone? When the slider moves on a fixed link having curved surface, instantaneous center lies on anyone? Center of curvature. Okay. Instantaneous center, you can see by looking at the figure, you will get instantaneous center lies on the center of curvature of the curvilinear path. Instantaneous center lies in the center of curvature of the curvilinear path of the configuration at that instant. Okay, instantaneous center lies on the center of curvature of the curvilinear path. So that is your answer. So that is the difference between C and D. Now you can see the last case. There you can see fixed link, one fixed link in the form of disk and all. You can see fixed link you can see, and one slider is moving. So what about the center? Instantaneous center in the last case. What about instantaneous center?
At the center of circle.
Center, it will lie at the center of the circle. Okay, so A, B, C, D, E, you can expect for your GATE examination. Okay, that is why we spend a lot of time here. This is very simple thing. Normally we will spend less time, but this thing is very important for your competitive level examinations. Very important. So you can expect one question from here for your mid as well as university. One word from will be from this A to E. Okay, you must understand the concept and study. So whenever a slider moves on a fixed straight surface, instantaneous center lies at infinity. Whenever a slider moves on a curved surface, curved fixed surface, instantaneous center lies at the center of curvature of the curvilinear path. So that thing you need to remember. C and D are very, very, very important. Also B case. When the disk rolls without slipping on a fixed link, the instantaneous center lies at the center of curvature. B means the instantaneous center lies at the center of curvature. So that is very, very important thing. And instantaneous center. So that two things, very simple thing that you have to study for your suppose the question is explain the properties of the instantaneous center, and you have to draw this diagram also. You have to study these diagrams, and how to locate the instantaneous center, you know. Then there is one theorem associated with the instantaneous center, that is your Arnold-Kennedy theorem. Arnold-Kennedy theorem. That theorem states that if three bodies move relatively to each other, they have three instantaneous centers. They have three instantaneous centers that lie on a straight line. So the theorem states, if there are three bodies, consider three bodies, and they move relatively to each other, then they have three instantaneous center that lie on a straight line. That we will discuss. Okay, that we will discuss. So that we will discuss that theorem in the form of a 4-bar mechanism itself. We will discuss that Arnold-Kennedy theorem. So you look at the figure 4-bar mechanism. 4-bar mechanism. Look at the figure 4-bar mechanism. Okay. So your question will be to identify the to locate all the instantaneous center. They will give one 4-bar mechanism, and they will ask you to locate all the instantaneous centers. 4-bar mechanism തരും ക്വസ്റ്റ്യനിൽ. എന്നിട്ട് നിങ്ങളോട് പറയും locate all instantaneous centers. Locate all instantaneous centers. Abhaya?
Yes, sir.
Abhaya. So,
Hello.
Abhaya, that is your question. A 4-bar mechanism is given, and you are asked to locate all the instantaneous centers. So what will be your step number 1? Step number 1? Clear allala Abhaya? Step number 1 will be, mechanism is 4-bar mechanism. Okay, Abhaya. Then Vivek.
Yes, sir.
Vivek, suppose the question is locate all the instantaneous center in a 4-bar mechanism. What will be your step number 1?
Sir, a mechanism വരച്ച് ലേബൽ ചെയ്യും.
Labeling. Then step number 2.
ഈ ഇൻസ്റ്റന്റേനിയസ് സെന്റർ ലൊക്കേറ്റ് ചെയ്യാനല്ലേ പറഞ്ഞിരിക്കുന്നത്. അത് നമ്മൾ ആ ഫിഗറിൽ കാണിച്ചാ പോരെ?
ഫിഗറിൽ കാണിക്കണം.
ഏതൊക്കെയാണ്?
അതെ.
ഏതൊക്കെയാണെന്ന് താഴെ എടുത്തെഴുതും. പിന്നെ ഇത് പ്രൈമറി ഏതൊക്കെയാണ്, പെർമനന്റ് ഏതൊക്കെയാണ്.
Okay. 1 minute, Vivek. See, Vivek, your step number 1 is very good. Okay, step number 1 means Vivek told he will draw and label all the things. That is very good. Step number 1. Okay, step number 2 means you are entering into one question, and straight away you can't mark what is fixed, what is primary instantaneous center, what is neither fixed nor primary instantaneous, neither fixed nor permanent instantaneous center. First, step number 2 means the examiner should know, or the person who is evaluating should know, how you know how many instantaneous center are there in the figure. So in step number 2, you have to calculate the total number of instantaneous centers in that particular mechanism. For that, there is one equation, n into n minus 1 by 2. So total number of instantaneous centers is equal to n into n minus 1 by 2, where n is equal to എന്തായിരിക്കും n, Vivek?
Sir, number of links.
Number of links in a 4-bar. 4. So you will get there are 6 instantaneous center. Then you will start marking. So Vivek, how you will start marking? Now you have the figure, and you know there are 6 instantaneous centers. So from where you will start marking?
സാറാ ഫിക്സ്ഡ് ലിങ്കിന്റെ സൈഡിൽ നിന്ന് സ്റ്റാർട്ട് ചെയ്യും.
Yes, fixed link in the you will start from the fixed link. Consider the link associated with the fixed link. One is fixed, so the adjacent links, link number 4 and link number 2, connect to that two links to the fixed links. So you will get your I14 and I12. That is a very simple step, and you will get directly, you will get the answer. I14 and I12 you can easily locate. Why? Because they are on the fixed link. Then what about next?
സാർ നെക്സ്റ്റ് നമ്മൾ മൂവ് ചെയ്യുന്ന ഇൻസ്റ്റന്റേനിയസ് ലിങ്ക് മാർക്ക് ചെയ്യും.
Mark you. Next step, it is also very easy. You can mark the other two links. The other two links, they are not fixed, and they will move as the mechanism moves. So they are called permanent instantaneous senders, and they are I34 and I23. Okay, I34 and I23. They are the permanent instantaneous senders. Then how to locate neither fixed nor permanent instantaneous sender? That is the concept, simple concept. Vivek, how you will locate the other two?
സാർ ആ ലിങ്കുകളെ എക്സ്റ്റെൻഡ് ചെയ്തതിനു ശേഷം അത് മീറ്റ് ചെയ്യുന്ന പോയിന്റുകൾ മാർക്ക് ചെയ്യും.
Yes, concept is you see, Vivek പറഞ്ഞ പോലെ തന്നെ concept is you have to extend some links which is not clear. See, when you extend two links, you will get that points. So which link you need to extend, that is not clear. Okay, so for that, in order to understand that, see, you are in need of I13 and I24. നമുക്ക് വേണ്ടത് 4 instantaneous sender. It is easy to locate the first instantaneous sender, which is clear from the diagram, 4-bar mechanism. But the remaining 2 instantaneous senders, which is your I13 and I24, it is difficult to locate. Why? Because you don't get directly, you won't get that I13 and I24. So for that, you have to draw one circle diagram. Nothing, no measurements are there. Just draw one circle. Just draw one circle, and inside the circle you draw one rectangle or square or anything. Okay, just draw one circle and draw one square. Okay, and mark 1 2 3 4. Mark 1 2 3 4. You mark 1 2 3 4. Okay, 1 mark ചെയ്തു, 2 mark ചെയ്തു, 3 mark ചെയ്തു, 4 mark ചെയ്തു. Forget about that pink colored line and all. You forget about that. You just draw one circle and draw one square inside that circle, square or rectangle, anything inside that circle, any dimension, and mark as such 1 2 3 4. Ini look at the thing. We are in need of I13. Suppose we are searching for I13. How to get I13? Okay, that is our aim. So you forget about these lines, these pink colored lines. You forget about what we are in need of. We are in need of I13. I13 എന്ന് പറയുന്നത് എങ്ങനെ ലൊക്കേറ്റ് ചെയ്യാൻ പറ്റുന്നുള്ളതാണ് നമുക്ക് പഠിക്കേണ്ടത്. For that, your 1 is here, 3 is here. Draw one line like this, I13. Okay, this is what we are required, I13. For that, in order to get that, you are extending two links. Extending two links. That means extending two instantaneous sender. Which are those instantaneous sender? Whenever you extend two instantaneous senders, you will get I13. Which are those two instantaneous sender? One is this one, I14, then next is this one, I34. I14 നെയും I34 extend ചെയ്യണം. Similarly, here also you have to do the same thing. I12, then I23. 1 2 2 3. Now look at the figure here. You look at here, I14 and I34. I14 and I34, you extend. Next, look at here, I12 and I23. I12 and I23, you extend, you will get your I13. So that is the concept. That is a very simple concept, very simple concept. Okay, very simple concept. So that is how you will obtain I13. The next aim is to obtain I24. ഇനി കണ്ടുപിടിക്കേണ്ടത് I24 ആണ്. So in your figure, there is no pink colored lines inside. You just draw one circle and inside that one square or rectangle and marked 1, 2, 3, 4. And your aim is to calculate I24. 24 ആണ് നമുക്ക് ഇനി വേണ്ടത്. Well, look at the 2, 4. Here you can see the 2, 4. 2, 4. This is your 2, 4. So you are in need of 2, 4. You are in need of 2, 4. This one is required. Okay. I24 is required. So what all instantaneous center you need to extend? That you will get from the left and right side of this inclined line. That means you have to extend. You have to extend. You have to extend. What you have to extend here? Here you have to extend your I12. I12. Here you have to extend your I12. I12. I12 എന്ന് പറഞ്ഞാൽ ഈ ഒരു ഭാഗത്തെ ലൈൻ I12 and I12 and then this one which is your I14. I12ഉം I14ഉം extend ചെയ്യണം. I12ഉം I14ഉം I12 and I14 you have to extend. Similarly, I23 and I34, so that you will get this one. So that you will get that. See, ഇതിങ്ങനെ എക്സ്റ്റെൻഡ് ചെയ്ത് പോവുക, ഇവിടെ എക്സ്റ്റെൻഡ് ചെയ്യുക, അതേപോലെ തന്നെ ഇത് എക്സ്റ്റെൻഡ് ചെയ്യുക. So that you will get your I24. Now you look at the figure here. I34. This is your I34 and I23 you have to extend on one side, and on the other side you have to extend I14 and I12. Here I14 is there, I24 is there. So whenever you extend these two lines, you will get your I24. This is the method, simple method for finding out neither fixed nor permanent instantaneous centers. Just this is very simple thing. So first time when you see, oh, this is the method and all, likewise you will look. The next time when you start solving, no need to draw the circle diagram and all. Whenever you see a 4-bar mechanism, you will get the concept. When you extend these two lines, you will get I24, and whenever you extend these two lines, you will get I13. And this is some theory behind that. A circle diagram ഉപയോഗിച്ചാണ് ഈ ഒരു I13ഉം I24ഉം കണ്ടുപിടിക്കുന്നത്. Whenever you do problem, you will not draw the circle diagram. There will not be time to locate circle diagram and all. Once, for understanding the concept only, I taught about the circle diagram. Okay, very simple thing. Okay, go through the instantaneous centers. Go through of instantaneous center. The recorded class of the instantaneous center. Last year I sent your seniors the recorded class, and that I will upload in your group. The recorded class is the instantaneous center. You go through the recorded class also, and also go through the definition and all the things mentioned in this slide also. Okay, that is very simple thing. Next class we will do the problems associated with the instantaneous center. So before that, you be thorough with the theory. For that, you can hear the recorded class as well as you can read the PPT. After that, in the next class, we will solve all the problems related with the instantaneous center, which is very simple once you understand the concept. Nothing is there, okay? So go through it. And if there is any doubt after hearing the voice recorded class and all, if there is any doubt today itself, you have to ask and clear everything. Once you clear all your doubts, you will start solving the problems. In one more class, every problems related with the instantaneous centers will be over. Okay. Okay, then Vivek.
Yes, sir.
Vivek attendance നോക്കിയിരുന്നോ?
അയച്ചില്ല.
Okay.
നോക്കിയിട്ടുണ്ട്.
Okay, then thank you all.
Thank you, sir.